Hello, I'm your instructor from the behalf of Campus Prep. Today we are going to start our coding lessons. In these lessons, we are going to see some competitive coding and how to attempt those questions so that you can prepare and you can actually attempt all the coding questions that will come on TCS NQT. So I have curated some questions from various sources, and I have also made an assignment sheet for all of you guys. So if you go in the description box below, you will find the link for the assignment. You can do the assignment yourself, you can run the codes yourself, and then like practice on this. So I'm going to discuss the concepts regarding solving a particular problem, and I will implement that concept in Python 3. So if you're comfortable in C++, if you're comfortable in Java, you can also use that language. That is your preference. I personally prefer Python because you have to write less syntax, and after writing less syntax, you can implement a logic faster. So let us start our today's lesson. I have curated some important problems and we are going to discuss them one by one. And again, you can find this assignment link in the description box below. You can all attempt this question, run this question, and check if you're getting them correct or not. So this is our first question. I am also doing in collab. This is my first question. The name of the question is CS01. This is our code, and the name of the question is string swap. So let us see what they are saying. You are given two strings s1 and s2 of equal length. A string swap is an operation where you choose two indices in a string, not necessarily different, and swap the characters at these indices. Return true if it is possible to make both strings equal by performing at most one swap on exactly one of the strings. Otherwise, return false. Write a function to solve this problem. So these are few of the input and output example. So we will understand this and then we will start with our question. So I have to write my code in this part and then I have to run my code. I don't have to make any changes at this part of this particular code. So what they're saying, you are given two strings. Let it be bank and K, A, and B. So let me write these two strings. So S1 is bank, B, A, B, A, N, K. This is bank, and S2 is K, A, N, B. This is another string. So this is string number one, and this is our string number two. So output is true. How? For example, if we swap the first character with the last character of S2 to make bank. So we can swap these two characters. We can swap these two characters to get bank. So I can bring B here and I can take K here, and our final result will be B, A, N, K. Fine. So you have to check if this second string can be made equal to the first string with at most one swap. If it can be made equal to the first string with only one swap, then we will say or we will return true. Otherwise, we are going to return false. So if we look into this second example given, the second example is A, B, C, D, and this is S1, and our S2 is D, C, B, A. So if you look into this particular string, so we have to swap these two strings. If we swap these two strings, we will get A, C, B, D. And again, we have to swap these two characters in this string. So we will get A, B, C, D. So we have to make two swaps to convert S2 to S1. So this is not our question. We have to use only one swap upon the characters. So this is our question. Let us go to the other additional constraints that are given. So they are saying that the minimum length of the strings, both of the strings will be 1, and the maximum length of both of the strings will be 100. Length of S1 and S2 will be equal to each other, and S1 and S2 consist only of lowercase English characters. So we don't have to check if all of those characters are small letters or not. We also don't have to check if both of the length of the both of the characters are same or not, and the maximum length the both of the strings can have is 100, and the minimum length that both of the strings will have is 1. So let us start with this question. So how can we actually solve this one? So for solving this one, what I'm going to do is that I'm just going to comment out this part for now. I'm going to comment out this part for now. And after commenting out, I'm just going to run this code or write this code for a particular input. And when I'm satisfied with my particular input, I'm going to uncomment this part and run this whole code. So what do we know? We know that for B, A, and K and K, A, and B, we are going to get true, and for this one we are going to get false. So at first we are going to write a program and check it against both these inputs. When I'm satisfied, I will uncomment rest of the part and we can do the rest of the codes. So anyways, so let us call this function. What is the name of our function? Name of our function is r almost equal. This function requires two arguments. If you look carefully at the parameter of the function given, this is our first argument and this is our second argument. This is S1 and this is S2. And this means that this function has to return a Boolean value. It requires two arguments, S1 and S2. One of the argument is a string argument and another argument is also a string argument, and this function is going to return a Boolean value. That means it is going to return true or false. So we will try out this function against our first input. So our first input is ABCD and the value for S2 is, oh sorry, this is BANK, K, and the second value is K, A, and B. So we are going to write K, A, N, B. Fine. So let us think like what can be our approach and how can we work around this question. So at first, I'm going to write all the indices that are present. So for S1, we have B, A, N, K, and for S2, we have K, A, K, A, N, B. So for S2, we have K, A, N, B. Okay. And let us just write all the indices that are present. So this is our zeroth index, this is our first index, this is our second index, this is our third index. Similarly, this will be also our zeroth index, this will be our first index, this will be second index, and this will be third index. Now we are going to check each of the corresponding indices. So this is an unequal pair, this is an equal pair, this is an equal pair, and this is an unequal pair. We are going to mark them separately. This is an unequal pair and this is an unequal pair. So what do we know? If we have to make one swap, or have we have to make one swap to change S2 from S1, then we should have exactly two unequal pairs. If we have more than two unequal pairs, that means we will require more than one swap to change S2 to S1. So if we look into the other example like A, B, C, D, and we have another S2 as D, C, B, A. In this particular example, this is an unequal pair, this is an unequal pair, this is an unequal pair, and this is an unequal pair. So as because it contains four unequal pair, it will require more than one swap for S1 to be converted into S2. So this is our false condition and this is our true condition. So we have to check number of total unequal pairs that are present in both S1 and S2. So for to check that, we can write a simple loop. What will be our simple loop? I can write for I in range len S1. In here, I could have written S2, len S2. I could have written S1. It doesn't matter because both of these strings have equal length. And we don't have to check if both of these strings have equal length or not because it is given in the question that like both of the lengths are equal. And we can see here in all the test cases, all the S1 and S2 number of characters in S1 and S2 are equal. So now we have to count the number of unequal pairs. So for counting the number of unequal pairs, I'm taking a count variable and initializing it to 0. When I have initialized it, now I will make a simple condition. What will be our condition? If I write S1 is not equal to S2I. If this particular condition is satisfied, that means we have got our one unequal pair. And for that, I'm going to write count plus equal to 1. Fine. After this loop is over, I can come out of this for loop and I can check or simply I can print. What I will print? I will print count. So what I'm going to do is that I'm going to run this code for both of this one. Once I'm going to run for ABCD and I'm going to run for this one. So I will just copy this part of this code, paste it here, and I will write S1 will be ABCD and S2 will be DC, DCBA. So for this first function call, number of unequal pairs will be 2, and for this function call, the number of unequal pairs should be 4 if I have done my program correctly. So I will run this code. Uh, when we run the collab code for the first time, it takes a little bit amount of time because you can see here it is connecting to this GPU. Once it is connected, all the other programs will run very smooth and very fast. So you can see here for this first function call, we are getting 2 as an output, and for this second function call, we are getting 4 as an output. So our function is working correctly. So now what I will do is that I will go inside this function, or I can just write a simple condition here. What will be our condition? I can say if count is equal to 2, that means it is possible. So I will just write here true for the time being. And if the value for count is more than 2, then I can print false for the time being. So if I run this code, I can see here for the first case we are getting true as it is given in the question, and for the second case we are given false as it is given in the question. Now we have to optimize this particular code and we have to check if this particular code is going to hold true for all the situations or not, or for all the input or not. So for doing that, what we have to do is that at first let us try to make this code a little bit optimized. So instead of this for condition only, I'm writing here count. If count is greater than equal to 3, greater than equal to 3, then I'm going to return false from this part only. Why? Because I don't care if the number of unequal pair increases from 2, or if the number of unequal pairs are greater than 2. I can say that I cannot change S2 to S1 with a single swap. From directly here, I can return false. If this whole if this whole loop runs, if this whole loop runs and we still have our count less than 2 or less than 1, we can say that we can change S2 to S1 using one swap only. So at this particular or outside this loop, in this for else part, I'm going to return true, or simply I can return true. But now, wait, there is a little catch in this particular situation. What is our catch? Let us imagine a particular input. S1 is A, B, C, D, and S2 is S2 is what is S2? S2 is A, B, C, or I can just write A here and X here. If you look into this particular input, we can see that this is one unequal pair and this is one unequal pair. So in this particular situation or for this particular code, this is going to give us true, that yes, we can change S2 to S1 using one swap only. But this is actually not possible, because if you look here, this is X here and X is not present in S1. So we cannot change S2 to S1 in infinite number of swaps only also. So this should gives us false. But the code that I have written here is giving us true in this particular situation. So what changes should I make in this particular code so that this situation gives us false? So one of the ways in which I can particularly do this code is that let us make all the uh, let us make a list of all the unequal pairs. So for S1 list, I'm taking like this, and for S2 list, I'm taking another empty list. Why I'm taking these two lists? I will use these two lists to store the unequal pairs from both S1 and S2. Every time I will get an unequal pair, I will append that value to S1 list and S2 list. So after I'm encountering an unequal pair, I'm going to write S1 list dot append, and after appending I'm going to append S1I in this particular list, and I'm going to append S2I in that particular list. Once I have done with this, let me come out of this loop, and I'm just going to print the S1 list, and I'm going to print S2 list. And for running this code, I'm going to use two kinds of input. One is I'm going to use two kinds of input, A, B, C, D, E, and this one X, E, D. So what do we know? So if I run this one, okay, for the first one, so just let me save this once and run this once again. Okay, why we are getting X? Okay. So anyways, I will just remove this false condition, A, B, C, D, and in here I will just write BC and then run this code. It should have given me the two different lists, A, B, C, D, and this should be B, C, A. And if I run this particular code, yes. So now I will just remove this first part and run only the second part. If you see the second part, we are coming in outside this for loop. But if we see these two lists, this is A and D, and this is X and A. So these two lists does not contain the same number of elements. So if we can just sort these two lists, we should get, if we just sort these two lists, or I can just use the sorted function. So if I run this code, I can see that both of the lists are coming different. But in the case of the previous output, if I run this code, you can see both of the lists are same. So what should be the two criterias? This is the same list and this is the different list. So what should be the two criterias? The two criterias should be, first, the number of unequal pairs should be 2, and the contents of S1 list and S2 list should be equal to each other. Then only we can say that S2 can be converted to S1 using one swap. So for testing this particular condition, what we can do is that I can write if sorted S1 list is equal to sorted S2 list, then I can return true, else I will return false. This is not yet done. We can still optimize this particular code. And whatever this one was, I will just include this code in our test results. So our input was S1 was ABCD and S2 was uh, X, B, C, and A. And for this particular output, we should get a result false. So let us try to run this whole code against all the test cases available here. So I will just uncomment this part of the code. I have uncommented this part of the code. I will just hide this code and I will remove this too because I no longer need this part of the code. So once I have done this one, I will just run this code. Okay, so you can see I have passed all the test cases. You can also try out writing the code on your own and check if you can pass all the test cases on it. Now, what is another non-optimal thing that we are doing in this particular code? Sorted S1 underscore list equal to this thing. This operation is already returning us the result in true and false. So we no longer need to check it separately with using if and else clause. So what we can do, instead of checking it in the if else clause, I can directly write sorted, sorted. What should we write? We should write S1 underscore list is equal to sorted S2 underscore list, and whatever they are returning is our final result. If they return true, that means yes, using one swap we can convert S2 to S1. If they return false, that means it is not possible. And this particular condition checks that yes, if there is more than two unequal pairs, that means it is not possible to change S2 to S1 using only one swap operation. So anyways, let us run this code again and we can check or we can see that we have passed all the test cases. So I hope this question was clear to you. If any part of the question was not clear to you, then you can leave a comment down below and we can have a discussion on your doubts. And if you find any better way to do this particular code, then you can also try this code and leave your code in the comment section below. So anyways, let us go to the next code below. So anyways, just let us read this question. So the question code is CS02 and the name of the question is minimum moves required. Given an integer array, it may be list. Given an integer array nums of size n, return the minimum number of moves required to make all array elements equal. In one move, you can increment or decrement an element of an array by one. So one move means you can increase the value of the element by one, or you can increase the value of the element by, you can increase by one, or you can decrease by one. So let us look into the examples that they have given below. So in the first example, they have given 1, 2, 3. Now, what are the possible conditions up here? I can change all the elements to 1. I can change all the elements to 2. And I can change all the elements to 3. These are our possibilities. In fact, you can change to 4, 5, 6, 7, 8. You can change in anything. Just that you have to make all the elements as equal. Only condition is that all the elements should be equal and the number of moves required should be minimum. And by number of moves or by a single move, you mean that increasing the value of an element by one or decreasing the value of an element by one. Any one is possible. So anyways, so we will restrict ourselves to this discussion only. If we take 4, 5, 6, 7, 8, 9, 10, so those are not going to be very much optimal in nature. So let us take this first case. So for 1, I can divide this thing into 3 parts. I can write here as 1, 2, 3. In here, I will change all the elements to 1. In this second one, 1, 2, and 3. For here, I will change all the elements to 2. And uh, for 3, I'm going to change all the elements to 2 here. 3. So now let us see what are the steps that are present. So for changing all the elemental value to 1, I have to decrease this once. So this will become 1, 1, 3. So this is our one step. I have to decrease it by 1. So this is 1, 1, 2. Because in one move, I can increase or decrease one value only. And this is another one. So this will become 1, 1, 1. So we require 3 moves to change all the elements to a single or homogeneous values. So now let us come here. I can increase this value to 1. So I can write 2, 2, 3. And I can decrease this value by 1. So I will write 2, 2, and 2. Fine. Now, so we will require 2 moves here. And for the last case here, so I will just change the color and write. Changing all the elements to 3. So for this one, for 1, so this will be 2, 2, 3, and in the next move, I'm going to write 3, 2, 3, and in the last move, I'm going to change it. I'm going to change 2 to 3, so I will write 3, 3, and 3. Now, if you look into all the moves that we require, this require 3 moves, this require 2 moves, and this require 3 moves. So the minimum moves that we require is for 2. So the minimum moves is 2. So in here you have seen here they have given here as 2. So this should be your answer, and they have also given the steps that are involved. Now, how we can actually do this one? We cannot use this naive brute force approach where we have to check all the elements possible and like we have to check all the minimum values possible. Now let us go to this one and let us try to devise an idea in which I can do this particular question. The second question is 1, 10, 2, and 9. Now, let us think. Uh, I can change all the elements to 1. I can change all the elements to 2. I can change all the elements to 9. And I can change all the elements to 10. So if you look closely, and if we arrange this list into ascending order, we have 1, 2, 9, and 10. These are the two extreme values. And to change from 1 to 10, we will require 9 moves. And from changing 10 to 1, we will require 9 moves. So we have to find a middle variable. We have to find a middle variable. That way, the distances will become very less. So let us try 2 here. For 2, for changing 1 to 2, we require only 1 step. For this, we will require 7 steps. And for this, from 2 to 10, from 2 to 10, we will require 8 steps. Fine? You're understanding me? From 2 to 1, you require 1 step. From 2 to 9, you require 7 steps. And 2 to 8, 2 to 10, you require 8 steps. So the total number of steps required is 1 plus 7 plus 8, that is equal to total 16 steps are required. Now the point is, we have to find the middlemost element after arranging the list into an ascending or descending order. And the middle element after arranging the list in ascending or descending order is known as the median. So first we have to find the median, and the difference of each of the elements from the median gives us the total number of steps required. So from 2 to 1 we require 1 step, from 2 to 9 we require 7 steps, and 2 to 10 we require 8 steps. So total we require 16 steps. So 16 is our answer. So we can test our theory at this output also. So what we can write, or we can say that 1, 2, and 3 is present. 2 is the median. 2 is the median because it is already sorted. And if it is already sorted, so from 2 to 1 it requires 1 step, and from 2 to 3 it requires 1 step. So total we require 2 steps. So this is also going to work in this previous case also. So what are our steps, or what is the procedure of solving the question? First, we have to sort the list, because it is not given in the constraints, or in fact it is not also given in the example input, that the input is given in the ascending order. So what we have to do, we have to sort the list in ascending order. That is our first thing. And after sorting the list, we have to find the median. And what should be the median? Uh, what should be the median? So let us just look into this list. We have 1, then we have 2, then we have 9, and we have 10. Index of 1 is 0, index of 2 is 1, index of 9 is 2, and index of 10 is 3. We required this element. So the length of the list is 4, and floor and 4. Okay, so there are 4 elements. So 4 divisible by 2 is giving us 2. So it should actually give us 9. So let us check if 9 is giving us the correct result or not. So from 9 it requires 8, it requires 7, and it requires 1. Yes, it is also given the correct result. So how we can find the median? Median is the element that lies at len of the list and floor division 2. Once we have found the median, we are going to find the difference from each of the elements present. And not just difference, we have to find the absolute difference. First, we have to find 9 minus 1. Then we have to find absolute difference. Then 2 minus 9, this is 8, this is 7. And then we have to find 10 minus 9, that is 1, and we have to add all those to get 16. This will be our total number of steps required. So first we have to find the median. So first we have to sort the array or list. So how we can sort? We can just use a single function for sorting the list, and the list that we are getting as an input is nums, and the return type of this function should be int, and it is mentioned here in this function prototype. So we have to write here, so what we should write? We should first sort this one. So we are going to write nums dot sort. As because nums is a list, we can use the dot sort function. Now that we have sorted the list, we have to find the median. Median will be equal to nums len of nums floor division 2 is our median. Then we have to find the total sum of the absolute difference. So anyways, let us try this once. Okay, we have found the median, and then we can find the total sum of all the absolute differences. So sum equal to 0, initialize it with 0 for element in nums. So what will be the values for element? The values for element will be each of the element present. So in this particular situation, it will be 1, 2, 9, 10. So we have to find an absolute difference. So we can write sum plus equal to ABS. Sum plus equal to ABS. Then we will write element minus median. Fine. And once we are done with this, we are going to return the value of sum. That is our question. Nothing more and nothing less. So I will just run it against the test cases that are given in the worksheet. So I will run this code and hope that I will get all my test cases back. So anyways, okay. So they're saying that test case 4 is failed. Check your solution. Now, let us think. We have this one. I guess this accepted output is wrong. So anyways, we can test and we can check why this expected output is wrong. So let us assume that our list is this one: 6, 9, 10, 13, 21. So there are 5 elements. So the median will be 10. Fine. So what will be the values of the element? The values of the element will be, at first it will be 6, and then it will be 9, then it will be 10, then it will be 13, then it will be 21. So these are all the values for 10, values of element. And now at each and every step, I'm going to subtract and get an absolute value with the median. So 6 minus 10 is 4. Then 9 minus 10 is 1. Then 10 minus 10 is 0. Then 13 minus 10 is 3. And 21 minus 10 is, I guess it would be 11, if I'm not wrong. So if I add all these numbers, so the initial value of sum is 0. So at first it will be s equal to 0 plus 4, that is 4. In the next step, it will be 4 plus 1, that is 5. In the next step, it will be 5 plus 0, it will remain 5. Then in the next step, it will be 5 plus 3, it should be 8, and s equal to 8 plus 11, it should be 19. So we can actually change all the elements in 19 steps. We will not require 29 steps. So there is a mistake in the test cases. So I will just change this one. So instead of 19, it should be 29, it should be 19. And I will just collapse it again, save this program, and run this program again, and check if we can cross all the test cases or not. Yes, I have passed all the test cases, so our solution is correct. So we have done with this question. So now let us go to this another interesting question. What is our question? Given a binary array nums, return the maximum number of consecutive ones in an array. So if the value for num is 110111, then output should be 3. There is also an explanation given here. So let us try to understand what they are saying in the question. Okay, so we have this list. What is this list? The list is 1, 1, 0, 1, 1, 1. How many consecutive ones are there? Maximum number of consecutive ones. We have 2 ones and we have 3 ones. So maximum consecutive ones that is present in the list is 3. So your output is 3. In this second example, we have 1, 0, 1, comma, 1, comma, 0, comma, 1. What are the maximum number of consecutive ones present here? This is 1, this is 0, this is 2, this is 0, and this is 1. So maximum number of consecutive ones present is 2. So the result is 2. So for a given list, you have to find the total number of consecutive ones that is present in the list. Now the point is, let us go into the constraints. They are saying that the minimum length of the list should be 1 and the maximum length of the list should be 105. And it is a binary list. It is a binary array now. So it is a binary list. That means each of the elements can either be 0 or either it can be 1. Like both of them, either it can be 0 or either it can be 1 only. There cannot be like 2, there cannot be 3 or something like that. Now my question is how we can solve this question. Let us think. Let us think using this example. We have 1, 1, 0, 1, 1, and 1. If there was some particular way in which I could change this list into this thing, I have filtered out all the consecutive ones like this to this and this to this. And once I have done this one, I can again change this to 2 and 3. And from this one, I can give the maximum value as our output. So this is my idea. What I have to do, I have to change this list to this list. Then I have to change this list to this list. Then I have to give the maximum value that is present in this list. So how we can do this? We have to convert this full list into string. This should be our first step. So let us check if we can do this thing. So we can do this, and for doing this, we are going to write a simple loop. One array. One array is a string, or I will not name it as array because it is a string. So one str is a string, and I have initialized it with an empty string. Now I'm writing for element in nums. For each of the element in num, I'm going to concatenate it to the one string. So I will write one str plus equal to str element. And let's check if we are getting and if we are able to convert this list into string or not. So I will just comment out this part for now, and I'm going to run this code bit by bit. So I will comment out this part. I will go here and I will run this code as max execute. What is the name of this very large name? So I will just copy this one. And inside this one, I will pass this thing 1, 1, 0, 1, 1, 1. So I have done this one. I will run this code. Okay, I have run this code because there is no output. So to see the output, I will just print the value of one str. So I will run this code now. So I can see that we are getting a string. Now that we have got a string, what we can do? We have converted into a string. So our string is something like this. 1, 1, 0, 1, 1, 1. What we can do is that we can split the string on the basis of your 0. I can split the string on the basis of 0. And if we split the string on the basis of 0, so we are getting this one element as an element, and this we are getting as a separate element. So what do we know when we use split function? We get a list where each of the element are the different splitted part of the string. So the element or the list will be 1 1 and 1 1 1. So after using split function, we should get this one. So before one str, I should write one str equal to one str dot split, and our splitting criteria is 0. So if I run this code now, you can see that I have separated 1 1 and 1 1 1 separately. So now if you want the exhaustive list of all the string operations or all the list operations or the tuple operations in Python, I will also try to attach the lists of functions in the comment below, in the description box below. You can check out those links and check out those notes as a reference material for your learning. Those are just reference materials, those are not meant for exhaustive learning. So for exhaustive learning, I would suggest you go through any of the given textbooks, but for as a reference material, you can go through the notes that I will provide in the description box below. So anyways, so we have done this one. We have converted it this one. Now we have what we have to do. We have to create another list. We have to create another list which will have all the numbers or all the length of the elements as their elements. So for that, writing a len list equal to an empty list, and for this one I'm going to write for row in len list, and I'm going to write len list dot append len of row, len of row. So and after that I'm going to print len list, and I will run this thing. So we are getting an empty thing. Oh, this should not be len list. There should be one list. So you're getting 2 and 3. And what is maximum of this len list? So I will just write max of len list. So that is 3. That should be our answer. So instead of printing the value, I'm just going to return the value. Don't worry, I'm going to optimize this code. So I will remove this part of this code and I will uncomment rest of the code. I will save this one and I will run this code. So I have passed all the test cases. Now that I have passed all the test cases, let us try to optimize the code bit by bit. First of all, I want to optimize this part of this code. So instead of writing like this, what I can do is that I can use list comprehension. Those of you are not aware of this particular phenomenon, or those of you are not sure or not clear on upon this concept, may consult the other resources on net and get clear about this concept. So anyways, so what I'm going to do is that I'm going to convert this thing or convert this loop into a single statement. So how we can do that? We can we can take this loop, I will cut it, and or I can just leave it here for your reference. I will copy this part. Fine. Now, instead of writing this one, I will copy this thing and write it in front of it. So, what is the anatomy of this list comprehension? Let us discuss it once with reference to this code below. This is your for loop part. This is your loop part or your for instruction. And this is your body of the loop. And I have enclosed this whole statement in third bracket. That means I'm converting this into a list. Fine. So I will remove this part of this code. I no longer need this one. So I will save this one. Fine. After saving this one, I will run this code again and I can see that I have passed all the 5 test cases. That means this is working correctly. Now I can actually simplify it more. I know this is giving us a list. I know this is giving us a list. And I am equating it list or initializing list to another value and then finding or then returning the maximum of that value. So what I can do is that instead of using another variable, I can just copy this list or just copy this statement and I can print it here and I can remove this thing. So I'm gradually reducing the length of the code. So I'm saving this one and I will run this code again so I can see that I have passed all the test cases again. Now, there is there are few more steps in which we can actually optimize the code. You can see here that I have written here as one str, and one str means one str dot split. This is a list. This is also giving us a list. So instead of using one more step, I can cut this part of this code and paste it. This is our full solution. I don't think there is any other way in which I can reduce this thing. If you have any other way in mind, please feel free to comment down below. You can also communicate with me directly in the Telegram group. So this is our final answer and we have passed all the test cases. So we are done with this part of the code. Now let us come to the last part of this code or last part of this session. What is our question? The question is, the question code is CS04 and the name of the question is power of a string. What do we understand by power of a string? Given a string S, the power of a string is the maximum length of a non-empty substring that contains only one unique character and return the power of the string. So how is it working? Let's see. So there are lots and lots of test cases given here. So I will just consult this test code and see if we can understand the question or not. So the input is lead code L E E E C O T E, lead code. If you look into this particular question, a particular input, we can see that we have two consecutive E, and that should be your answer, or that should be power of a string. That means you have to find the total number of consecutive characters or the highest number of consecutive characters that is present in a string. Now let us look into this one also. So what we have? We have A, then we have B, then we have three C's, then we have four D's, and we have five E's. 1, 2, 3, 4, 5, and then we have a single D, then we have a C, then we have a B, and then we have a E. Now, this is one consecutive characters, like we have two B's, so we have 2. Then we have C's, that is 3. Then we have D's, that is 4. And then we have E's, that is 5. And this is 1, this is 1, 1, and 1. And this is also 1. So they are out of our contention. Now let us see here, out of this one, our maximum is 5. So the power of this string is 5. So how we can actually find the total number of consecutive characters that are present in a string? So we will try out with this output, or yes, we can try out with this output. So this will be a bit long, so we will try out with this output. So what I'm going to do is that, what I have done in the before questions also, I will just comment out this part of this code. I have commented out this part of this code. Now let us try to calculate, or let us try to display all the consecutive characters that are present in a string. So how we can actually do this? So let us write a simple for I in range 1 comma len s. S is an argument and s will be the value that we are getting. So what will be the value for I if our input is lead code? So I will just call this function with an value of lead code. So I will just copy this part, paste it here, and as an argument I'm going to pass lead. We are done with this one. Now that we are done with this part, let us go here again. Now, what should be our values for I? The value for I should be, we are starting with 1 and then we are ending it Lennis. So we have lead code as an, the value of S is lead code. So the length of the string is 1, 2, 3, 4, 5, 6, 7, 8. This is 4. So this will be 8. So the possible values for I will be from 1 to 7 because we don't include this number. So the values of I will be 1, then we have 2, then we have 3, sorry, then we have 4, then we have 5, and then we have 6, and then we have 7. These are all the possible values for I. And then what will be the possible values for Si? The possible values for Si will be E, E, T, C, O, D, E. These are our possible values for Si. Now now to get the consecutive characters window, we have to check if this particular character is equal to the previous character or not. So we have to start from 1 and we have to check if this character is equal to this thing or not. So what we do is that we take a variable count that is going to count the windows that is present, count equal to 1, and we take another variable that is max count. So count equal to 1 is going to take care of all the uh, number of occurrence of each of the continuous character, and max count is going to calculate the maximum window that is present. So from here, let us try to do if Si if it is equal to Si minus 1, then what we are going to do is that we are going to increase the value of count by 1. Fine. That means we have encountered some, or we have encountered a consecutive character. Once we are done with this, what should be our next condition? Our next condition should be we have counted or we have incremented the value of count. Our next condition should be if the value of count is more than max count, then we should initialize max count with count and again this thing. So now let's check here. If the value for Si is equal to its previous value, then we increase the value of count by 1. Now then we check the value for count, and if it is greater than max count, then we reinitialize max count to count. Now I have given here two if, not if else? Because I want both of this condition to be executed separately. So that is why I have given here two ifs. And there is one more condition. If Si is not equal to Si minus 1, then I will again initialize the value of count to 1 because I have no longer the continuous characters. So that is why this thing. And once we are done with this, I will just return the value for max count. Fine. So I will save this code and I will just write on this code once. So what we have? We have Si is equal to Si minus 1. So Si is E and Si minus 1 will be L. So is this equal to L here? No. So is count value of count is 1 and value of max count is 1. Is count greater than max count? No, condition is not satisfied, but this condition is satisfied. So the value of count will become 1. Now in the second case, S2 is E, S1 is also E. So this condition is satisfied. So value of count will become 2 and 2 is greater than 1. So that is why max count will also become 2. Fine. Next thing, T is equal to E. No. So the value of count will again become 1. So this will remain 2. Now, C is equal to T. No. Is O equal to T? No. Is D equal to T? No. Is E equal to D? No. So after this loop is over, the value of max count is 2 and this is the value of power of the string. So I will just uncomment the test cases and try to run this code against the test cases. So what I will do is that I will remove this part of this code and I will uncomment this part of this code. Once we are done with this, I will collapse this part and I will run this. So I have seen here, I have passed all the test cases, so our solution was successful. So I think that's enough for today's lesson. I will come back again on Wednesday with some few more important coding questions that you might get. I am not saying that you will exactly get these questions, but having this practice of these questions or having practice of competitive coding will give you an edge over the other candidates in TCS NQT. So I will come with more coding questions in the next class. Meanwhile, you can try the assignment of this course. It is given in the description box below. You can also visit our website for the other aptitude test questions, logical questions, and verbal questions. And you can join our Telegram group and Facebook page and Instagram page. All the links are given in the description box. So I am signing off for today. See you on Wednesday. Bye bye.